The decision algorithm is a framework to classify when to use the additive principle and when to use the multiplicative principle. The language of the decision algorithm is that alternatives are used to describe cases of using the additive principle, and that steps describe cases in which we use the multiplicative principle. Choosing a soup or salad. Soup and salad are two alternatives. They're alternatives because you're not trying to choose both of them, you're trying to choose one or the other. Choosing size and flavor of ice cream. Here, size and flavor are two steps. To complete a full order, you need to first choose a size and then also choose a flavor. Here we see the decision algorithm being used to classify some unseen problem. The decision algorithm orders material in layers. This outer layer is a step, so this outer layer will employ multiplication. Within each outer layer, we also see that we have sublayers. The sublayer for step 1 are alternatives, which employ the additive principle, and similarly, this inner layer of step 2 also employs alternatives. To get a final number of outcomes from a setup like this, we want to start at the innermost layers and work outwards. To work outwards, we'll employ either the multiplicative or the additive principle. Here we have two innermost layers. This first inner layer is alternatives, so we want to add the three outcomes. We'll have 3 plus 2 plus 1. This means that step 1 had a total of 6 possible outcomes. Our second innermost layer again involves alternatives, so we have 2 plus 2 to find that step 2 had a total of 4 outcomes. Next, we want to move to our next layer, which in this case is our largest layer, our outermost layer, and we have steps, which means we want to multiply, and we have 6 times 4, which will be 24. In this scenario, there are 24 outcomes. Here we have another scenario that's already been set up using the decision algorithm, and we'll go over how to interpret what's been set up. Here, the outermost layer of alternative 1 and alternative 2 are arranged in a horizontal layout. We can imagine this material as if it was presented in the vertical layout of the previous problem. Here we'll see that the outermost layer involves these two alternatives, and that in each of these there are sublayers. And in this second sublayer, we have an even deeper layer. To reiterate, we want to work at the lowest layers and work out. Our lowest layer is this case, where step 1 is 4 outcomes and step 2 is 3 outcomes. Again, steps are when we want to do the first and then the second. That and then clues us into this notion of multiplicative principle. And we'll say 4 times 3 to get this alternative 3, of which these two steps are a sublayer, has 12 outcomes. We can now move to the next layer up. Here we have two steps, step 1 and step 2. Again, steps are multiplicative, so we'll have 2 times 3 to get 6, which tells us that in our outermost layer, the number of outcomes for alternative 1 is 6. On to our next layer. Alternatives clue us into the additive principle, so we want to add 2 plus 4 plus 12, 12 being something that we calculated earlier, to get 18. At this point, we can do our outermost layer of two alternatives. So we'll do 6 plus 18, which gives us 24. In our next video, we'll go over how to go from word problems to setting up arrangements like these.